in pinacol-pinacolone rearrangement, it is an acid catalyzed rearrangement. It is an acid catalyzed rearrangement of vicinal diols. Means 1,2 diol. The OH groups must and should be placed on the side adjacent to carbon atoms. In such cases only this pinacol-pinacolone rearrangement is possible to see. So this will change to carbonyl carbon. Carbonyl compound. So known as pinacol-pinacolone rearrangement. So from here onwards I will reduce the writing part. One I will explain the concepts. First of all, let us see what is pinacolone. But all the compounds that are going to participate in this rearrangement are not the pinacol and pinacolone. But since they are having the similar structure as the pinacol and pinacolone, all are called as the pinacol-pinacolone rearrangement. See, this is the actually pinacol. This is called as pinacol. Okay. So when this pinacol means diol, hydroxy groups must be placed on the adjacent carbon atoms. Is subjected with the H plus ion. H plus ion means it may be this H plus ion may be from the dilute sulfuric acid or from the dilute H3O4. So what happens finally is the molecule will be rearranged in such a way that it gives a carbon compound. This is called the pinacolone. Let us see the mechanism, then only you can understand what actually is happening here. So in this mechanism, first of all, let us take this molecule, pinacol. And H plus ion will be attacked by any of these OH groups. See here you may get the doubt. Sir, here two OH groups are there. Then which OH group actually attacks over the H plus ion? Since here all similar carbons are there, so that any of these can be attacked by over the H plus ion. But the question is, if any different groups are there, so among them, which is able to provide the stable carbocation? Because of the attacking of the H plus ion, this will be eliminated as the H2O. So positive charge will be developed over this carbon. And if these particular groups are able to provide this stability to this carbocation, then H plus ion preferably will be attacked by that particular OH, or else it will not get attacked. Now let us see here. CH3, CH3, OH, OH, hydronium. We know that OH2 plus is a very good leaving group. So immediately it will be removed as H2O. So that electrons will shift here, this carbon gets the positive charge. So now this electrons has to shift this side. But if this electron shift here, the valence of the carbon crosses 4 because already 4 valence is there. So that is the reason why one of this methyl group will shift over here. So that we call it as a methyl shift. This is very important reaction. Please write down this reaction in your notebook. So now this H will be removed. So finally here carbocation will be developed on CH3, C double bond 1, C, CH3, CH3 and CH3. This is for the chemical. Okay. So you may get the doubt, sir, here this side of the CO, here we put the CO, both are same. Since it is a symmetrical molecule, so that we can take the CO group inside, the name of the AUPAC name of the molecule remains the same. So let us take the another similar compound. All these CH3 groups is just placed in the phenyl group. So whenever diols are the H3PO4 is element, you must remember this particular reaction. Okay? That diols also, you should remember that they are having at least one carbon atom. So now molecule will be PH double bond PH. Means one of the phenyl group will go other side, and from where the phenyl group or alkyl group has left, that carbon gets the double bond O. Okay? Now here in this particular case we have seen that here methyl phenyl group is shifted, here methyl group is shifted. But if both are there, both methyl group and phenyl group are there, then which group gets shifted easily? So that let us see now. So migratory order. This is important for you. Migratory order of general groups is hydrogen migrates very easy than the aryl group than the alkyl group. Okay? And within the aryl groups, migratory order of the aryl groups. So electron rich group migrates always first. You must remember that I am explaining I am saying very clearly that electron rich groups migrates preferably. We think that this is a link, not the methyl group. Means it is connected to some carbon atom. Okay? You know that this OCH3 is the best electron releasing group among these groups. So that it preferably means within the aryl groups, this group both are present, this group will be shifted. Later this one, and this one. And within the alkyl groups, when the length of the chain increases, the tendency to shift also increases. For example, if you take alkyl groups, within the alkyl groups, both methyl and ethyl. So ethyl group will shift from more preferably than the methyl because it is electron rich group, which can release the more number of electrons through its plus I effect. So now let us see some other examples, which are very good examples. Now we can see So here I put the pH, OH and OH. Again this is symmetrical group, symmetrical compound. So that at one particular carbon atom, positive charge will be created. So for example, at this particular area, positive charge is created, then phenyl group and methyl group both are present. Phenyl group will be shifted preferably, so that the group finally becomes CH, double bond O, CH. This is the answer. Let us see one more molecule. Now this is completely unsymmetric. Here methyl, phenyl, OH one side, here also methyl, phenyl, OH other side. This is symmetric. It is completely unsymmetric. So in this particular case, if you put the H plus ion, see, if H plus ion attacks over this first, that I just consider as a first, but not actually first, this is second OH. So if H plus ion attacks over the first OH, here a positive charge will be created, which is a tertiary carbonate. And if the H plus ion attacks over this OH and leaves this H2O, so positive charge will be created here. This is not only tertiary, but is a secondary phenyl, secondary benzene. So this is a benzylic carbonyl. So the preferable attacks over here, so that a positive charge shall be created here. So that one of this methyl group will be shifted this side, so that double bond will come here. Okay? This is the molecule. Now let us see another molecule. So now in the next molecule it is similar one, but I'll change certain groups. CH, hydrogen, CH3, OH, OH. Now I'll give H plus. H3 give or H2, so what I'll do? Stacking concept is same, because if it stacks over here, positive charge shall be stable. So then migration must take place from the adjacent carbon, whether hydrogen or methyl. So hydrogen migrates here. So the double bond O will be formed here. So that you should write very systematically that the coming group is hydrogen here. And here double bond O CH. Now let us take this particular molecule, hydrogen, hydrogen, OH and OH, H plus N. So that again here there is a positive charge. If it is formed, this is the primary, this is the secondary. So that positive charge H plus N attacks over the positive charge is created here. So hydrogen shift that side. CH3, this is CH2, CH. Or else if you want to write down this molecule in normal way, so that also I shall explain. That is here CH3, already hydrogen is there, new hydrogen is coming here, and here hydrogen is present, double bond. What is this? CH3, CH3, CH2, CH2. Both are set. Okay. Let's take some other good examples also. So here, OH, CH3, CH3, OH. So that H. Now the doubt arises among the people that whether H plus attacks over here or here, because both are tertiary and no phenyl group is there. The question is, if H plus attacks over here, the positive charge shall be created. Means carbocation hybridization is sp2 hybridization, bond angle is 120 degrees and shape is a planar. But the same H plus attacks over of the carbon. Then here link is there so that it cannot develop the 120 degrees bond. So that H plus ion preferable attacks over here. So afterwards what happen here, positive charge shall be created. So I am going to write down the mechanism of this particular reaction. Now ring expansion takes place. So it will become a 6-member ring. So in the 6-member ring, one particular carbon is having the 2 CH3 groups on one carbon atom. And the adjacent carbon will get the positive charge. There only OH group is present. So now loss of H. So this is the molecule. Hope you understand this molecule. So I'll use some 2 more molecules also. And you please solve this now. H plus ion attacks any of these OH groups. Let this OH groups attacks over H plus ion. Positive charge OH. So there is no option except for the ring expansion. So that it becomes 1, 2, 3, 4, 5 number. This from here you have to count 1, 2, 3, 4, 5. So 1 is the 5 number ring. That 5 number ring I am writing this. We can write in that side also. Okay, I shall write here. This becomes the 5 number ring and the 4 number ring remains as it is. And whenever this particular carbon shifted here to the 4 member ring and the next carbon means one of these carbon atoms are losing the positive charge. So anyhow this is connected. So 2 carbons are connected to this particular area, this fused carbon. So one of these carbon atom gets the positive charge as well as OH group. Later loss of H plus ion. This is the molecule. Now let us see some abnormal cases also where you don't find the both the OH groups but still they show the phenocone rearrangement mechanism. Here OH, CH double bond CH2, H plus ion attacks. So when H plus ion attacks, then again generally doubt stands whether it attacks over the OH group or this particular alkene path because electromeric effect, positive electromeric effect. The preferable attacks over the this particular alkene why because carbon hydrogen bond is so strong. So that gives the bond like this. CH. Hence according to the Marconi capsule, H plus ion has to attack means positive part of the reagent has to attack over the carbon with more number of hydrogen. CH3 and this is the positive charge. Now this is a 3-membered ring, so that again ring expansion has to happen. So ring will expand like this. So it becomes a 4-membered ring now. So in this 4-membered ring, so including this carbon membered ring, that is having CH3 group. So that adjacent carbon must have the OH group with the positive charge. Shifting of this H plus ion, loss of H plus ion. So this shall be double bond or this shall be CH. And some other reactions also there. I will give you those reactions. Very important reactions. They look like phenol reagent. Ag plus. So what did you understand from this concept? It is simple thing that, see, adjacent carbon atom, a OH group, compound having the OH group, and its beta carbon atom is able to provide the positive charge, then that shall participate in the phenol rearrangement. So here Ag plus is there, Ag plus react with the Cl and it will be precipitated as silver chloride. So that positive charge comes over here. So any organic compound having OH group and able to provide the positive charge on its beta carbon atom, able to show the phenol rearrangement. So now here methyl group shifts takes place here, methyl shift, so that CH3 C double bond O PH PH and CH. So this is the molecule. Now I'll give some examples for you. You please solve this phenol rearrangement reactions at your home. This reaction is so important because most of the people they don't practice this in particular question, but still this question is there in your NEET exam. It's not forgettable. Your NEET it is there. CH3 C2H5 H H. Just I am writing the only reactant molecules. So these are all reacted with H2S support and able to provide the phenol rearrangement. We write down the major product. I'm just giving the reactant molecule. ABC. So these four examples you please solve at your home. Okay. So that now I'm going to discuss one of the best and important concept of the alcohol chapter, that is oxidation of the alcohol. Even I will make a separate video on this one and release it like lithium aluminum hydride and sodium hydride. Hope you might have seen that lithium aluminum hydride and sodium hydride. So, but anyhow, this type of real explanation is so good. So that I'll explain the oxidation of alcohols. I'll explain the key points of these alcohols first to make you very understand about the concept. As people get confused of these particular concepts, you always remember one thing, that any alcohol, when undergo oxidation, primarily develops carbonyl compound. I'll write down the carbonyl compounds. So that carbonyl compound may be aldehyde or it may be ketone. And these carbonyl compounds on oxidation finally shall be converted to the carboxylic acid. So this is the normal procedure. Even lithium aluminum hydride reaction, sodium borohydride, we have seen that the opposite reaction is called reduction. So carboxylic acids, ketones and aldehydes, they finally produce the reduction gives the alcohol. That we had already seen. So now, in this particular question, alcohols and oxidation gives aldehydes, ketone, that means carbonyl compound. This carbonyl compounds and oxidation gives the carboxylic acid. The real question arises that certain reagents, certain oxidizing agents will stop the oxidation of the alcohols at the carbonyl stage itself. But there are some strong oxidizing agents which will not stop the oxidation of the alcohols at the carbonyl-carbon stage. But even though these also shall be oxidized to the carboxylic acid. So there are only three oxidizing agents, and such oxidizing agents are only three that we shall discuss. Rest of all oxidizing agents converts alcohols to the aldehydes and or ketones. Then which alcohol gives the aldehyde and which alcohol gives the ketone? That I'll explain here. General example I shall explain. I'm not taking the oxidizing agents at now. I'll explain the oxidizing agents separately now. So this is a primary alcohol. Primary alcohol. So here it is having the two CH bonds. Only one hydrogen bond has to be removed every time, so that we get the RCH aldehyde. Another carbon hydrogen bond still remains there. And if you take this particular alcohol, CHOH, what does it mean? This is secondary alcohol. How many carbon hydrogen bonds are there? Only one carbon hydrogen bond is there to the OH bearing carbon. So that has to be removed, so that you get the R double bond O R ketone. So primary alcohols and oxidation gives the aldehydes, whereas secondary alcohols and oxidation gives the ketones. This is aldehyde and this is ketone. Then what about the tertiary alcohols? Tertiary alcohols and oxidation. Any carbon hydrogen is there? No carbon hydrogen bond and no oxidation. So alcohols in which OH bearing carbon having at least one hydrogen shall be oxidized. So primary alcohols gives the aldehyde, secondary alcohols gives only ketone, and tertiary alcohols do not get oxidized. So let us see what are the oxidizing agents and what about their properties now. And here I am not going to discuss one thing, that almost all oxidizing agents they convert the secondary alcohol to ketone. Our main discussion is about which oxidizing agents stop the reaction at the aldehyde stage. Why? Because this ketone cannot be oxidized. Oxidizing agent, whatever we are going to discuss, cannot oxidize this ketone to the carboxylic acid. The reason here is this reaction is not possible because it has to break the carbon-carbon bond. So oxidizing agents do not have that much efficiency to break this carbon-carbon bond unless and until you are using the highest heating process. If heating process is not there, means highest heating process, then ketones cannot be converted to carboxylic acid. So whatever the oxidizing agents we are going to discuss, almost all oxidizing agents, they oxidize the secondary alcohol to the ketone. But our main discussion is about which oxidizing agent stops the oxidation of the primary alcohols at the aldehyde stage, and which will take this process till the carboxylic acid stage. So now let us take these important oxidizing agents. So first of all, I'll write down the oxidizing agent. The oxidizing agent. Please remember oxidizing agent. Second one is, let us take the secondary alcohol to ketone. Next one is primary alcohol to aldehyde. Next one, primary alcohol to carboxylic acid. Now, first one compound is H plus or OH minus, acidified or basic, KMnO4. On heating, converts the secondary alcohols to the ketone, converts the primary alcohols to aldehyde, and aldehydes will be again oxidized to the carboxylic acid. So it will not stop the reaction at this stage. It will carry out the primary alcohols to the till carboxylic acids. Second one is H plus K2Cr2O7. You must remember that KMnO4, K2Cr2O7, they are the strongest oxidizing agent. So they do the same process. Primary alcohol, carboxylic acid, secondary alcohol, ketone. So they cannot stop the reaction at the aldehyde stage. And the third one is Jones reagent. Jones reagent means it is, you must remember Jones reagent. CrO3, dilute H2SO4 and acetone. This is called the Jones reagent. So this is also doing the same thing. So these are the first three reagents which convert the secondary alcohol to the ketone and the primary alcohol to the carboxylic acid. They don't stop the reaction at the aldehyde stage. And whatever the reagents we are going to discuss now, they all stop the reaction of the primary alcohols, oxidation of the primary alcohols at the aldehyde stage. So fourth one is I am giving this one, just remember, even reagent structure you don't need to remember, just I am giving this structure. This is called as the Pulling's reagent, dipyridine, pyridine 2 or the dipyridine chromate. Also known as the Pulling's reagent. Pulling's reagent. So converts the secondary alcohol to ketone, primary alcohol to aldehyde. This is not what. And fifth one. You just put only this chart. Rest of the don't by heart the reactions. Only this one is enough. And next one is PCC, that is Pyridinium chlorochromate. This is called a Corey's reagent. And the structure of this one. So this is called the PCC, Pyridinium chlorochromate. Pyridinium chlorochromate, PCC. It is also called the Corey's reagent. So its work is also same. Sixth one, PDC, Pyridinium dichromate. This is called the PDC, Pyridinium dichromate. So this Pyridinium dichromate also does the same thing, that secondary alcohols to the ketones and the primary alcohols to the aldehyde. It will not convert the primary alcohol to the carboxylic. These are all mild oxidizing agents. And Seventh one is the DMSO, dimethyl sulfoxide. Dimethyl sulfoxide, and actually its structure is sulfur oxygen, two methyl groups are connected. So it is also doing the same thing. So you need to remember one thing, that except these three reagents, if you remember, that's enough. H plus KMnO4, H plus K2, everybody remember, only this combination, CrO3 dilute H2SO4. So these are all strong oxidizing agents. Strong oxidizing agents. Okay? And rest all, whatever PCC, PDC, Pyridinium, dipyridine chromate, this one, Cullin's reagent, and all these DMSO, these are all mild oxidizing agents. So they stop the aldehyde stage. Again, aldehyde will not be oxidized to the carboxylic acid by these last reagents, but first three reagents are the same thing. Last four reagents they don't. And apart from this, there are many other. So let me discuss this one. Later we shall go to the another oxidizing agents concept. Very important oxidizing agents are. That's why I told you that today's lesson is also so important for you to understand. And like lithium aluminum hydride video, this video also you need to see repeatedly. So CrO3, dilute H2SO4, acetone. What is this? So this is Cullin's reagent. So primary alcohol actually to be oxidized to the carboxylic acid. But this Jones reagent has one different concept, that benzyl alcohol to be converted only to the aldehyde. Some exceptional reactions are there. This is means, okay, I'll give one important thing that regarding the Jones reagent, because this is a selective reagent, it do something this one, something this one. It is always, I'll put this one as a star mark. The reason here is star mark means here conjugated alcohols will be converted to the aldehyde. Non-conjugated aldehydes will be converted to the carboxylic acid. Then your doubt is clarified. So this is conjugated alcohol, here double bond will be there. So if any CH2OH or CH2OH are to be connected to the double bonded carbon atom, then they shall be converted to the aldehyde. So we'll take one more example about this one. CH2OH is same. So only this shall be oxidized. CH2OH, CH double bond CH. So you can see. Let us take some other examples also. These are just normal examples. Secondary alcohol, primary alcohol. So you must be aware of which is the reducing agent, which is the oxidizing agent. Na2Cr2O7. What is sodium chromate? Sodium dichromate in the presence of H+. Instead of potassium dichromate, here is the sodium dichromate. Sodium potassium is not the metal, but chromium must be in the +6 oxidation state. So it is the strongest oxidizing agent. It converts this secondary alcohol to the ketone, primary alcohol to the carboxylic acid. OH. Use the same reagent. No oxidation, because it is a tertiary alcohol. OH and OH. Use PCC, pyridinium chlorochromate. What is the duty of the PCC? It converts only primary alcohol to the aldehyde, secondary alcohol to the ketone. So this is the primary alcohol, so that you will get the aldehyde. This is a tertiary alcohol, so that it cannot be oxidized. So apart from these oxidizing agents, these are also important oxidizing. You have to make one chart and paste it in your room regarding the oxidizing agents and reducing agents, because the same agents repeatedly appear in the organic chemistry. Next one, Ceric ammonium nitrate. This is also one oxidizing agent. Ceric ammonium nitrate is called as CaN. Ceric ammonium nitrate is very selective reagent. And it is a mild oxidizing agent also. So what is the duty of this mild oxidizing agent means? It oxidizes aromatic methyl group. Means it oxidizes only primary alcohol to the aldehyde as well as aromatic methyl group. Aromatic methyl group means the methyl group that is connected to the aromatic ring also shall be oxidized to the aldehyde. So it's an extra duty, means what we call is having some extra okay. So it's converting the primary alcohol to the aldehyde and aromatic methyl group to the aldehyde. Only aldehydes will be formed from this can. I'll take some examples. So here we shall take CH3, CH2, OH, CAN, CH3, CH2, aldehyde. Primary alcohol with CAN, aldehyde. So aromatic ring I have taken here, OCH3, here CH2OH. Use this one, OCH3. So this is CH2. And here, this is not the aromatic methyl group because oxygen is present in between. So I'll take one more example, similar example. Aldehyde and aldehyde. Because this is aromatic methyl group. So its main duty is to convert the primary alcohol to the aldehyde as well as aromatic means benzylic carbon, benzylic methyl group to the aldehyde. So that is the CAN. So you have to make one particular chart. Then apart from this, there are three more oxidizing agents in that manganese oxide. What is the duty of the manganese oxide? It is also very selective and mild oxidizing agent. It is very specific for the allylic and benzylic alcohols. To their respective aldehyde or ketone. Means it is preferably whenever allylic or benzylic alcohols are, then you select the MnO2. So I shall take here one example that CH double bond CH2 is a primary allylic alcohol. Use MnO2 so that you will get the CH2 double bond CH2 aldehyde. But for the same CH2 double bond CH3 OH, secondary allylic alcohol, if you use MnO2, then it will give the keto group. Means its main duty is to oxidize only allylic and benzylic alcohols, not other parts. So I shall take some other regarding the benzylic group also. See, this is the secondary benzylic alcohol with MnO2 keto group. Okay. So now I am taking one important example because you should not get confused of this. See, the example is how much this important. MnO2. This it oxidates, MnO2 oxidates only benzylic alcohol, and this is completely unaffected. So that this is OH, this is OH. But if you use any of the earlier oxidizing agent, they convert the secondary part to the keto and the primary part to the aldehyde. Okay, any of the other oxidizing agents except the three. If you use the first three, this is secondary alcohol to the ketone, that is common, but primary alcohol to the carboxylic acid. But apart from the first three, H plus KMnO4, K2, Cr2O7, Jones reagent, Cr2O3, H2SO4 and H2. If you use PCC, PDC, DMSO, any of those, the dipyridine chromate also, then they convert secondary alcohol to the ketone, primary alcohol to the aldehyde. But if you use MnO2 oxidizes only benzylic alcohol and allylic alcohol to their respective oxidized carbonyl compounds and not touching the another part. But what is the use of the CAN, ceric ammonium nitrate? CAN main duty is to convert the primary alcohol to the aldehyde and benzylic methyl group to the aldehyde. So use the CAN here. Use the CAN here. So CAN will touch only this particular part, primary alcohol to the aldehyde, and it will not touch here because its OH group is there and here CH3 is not there. And now another one, that is, already you have studied this, is there in the your NCERT textbook, copper with 300 degrees centigrade. It simply gives the primary alcohol to the aldehyde, secondary alcohol to the ketone, and it oxidizes the tertiary alcohol to the alkene. So that I am not necessary to discuss. Anyhow, this is the NCERT. Okay, if you want means I will give an example of this tertiary alcohol only. We will take tertiary alcohol because secondary alcohols you can get any of those earlier examples. Copper with 300 degrees centigrade, you just convert the CH3, CH3, means dehydration takes place, hydrogen here, OH here. So the double bond will be developed. Alkene will get in the case of the tertiary alcohols. The primary secondary alcohols are oxidizing. The tertiary alcohols are dehydrated. And one more example of the silver chromate, silver carbonate, Ag2CO2, Ag2CO2, silver chromate, carbonate. So this silver carbonate is also highly selective and oxidizing only primary and secondary alcohol to the aldehyde and ketone. Primary alcohol to the aldehyde, secondary alcohol to the ketone. Then what do they use this reagent? Because its duty is also similar to the other reducing agents like PCC, PDC and all. The importance of this reagent is if any alcohol, secondary alcohol is covered with the bulkier groups, then it will not oxidize in secondary alcohols also. H2OH primary alcohol, use Ag2CO3, so that pH, CH2 aldehyde. Ag2CO3 in the presence of the benzene. So here this OH is completely free, so this shall be oxidized. The aldehyde. So this is the today's session.